Okay, so the last type of transformation that we're going to talk about is rotation. And rotation is usually the one that seems to be like the most difficult of them to plot correctly or to visualize. But we're going to talk about basically how to just change it on a coordinate plane to make it work for you. So hopefully that will make the whole process of rotations easier. So before we start, let's say, so Miguel, you were doing what with your head when you said it's like this?
It's in one thing. It's like a clock.
Yeah, it's like a clock. So if it's like a clock, that means it could go which way?
Clockwise.
Clockwise or counterclockwise. So essentially clockwise means it's turning around a clock the way that a clock turns. Counterclockwise would be the other way. Okay, so when we talk about rotations, it rotates around a center. So it rotates around a point. So in this one, A and B, is A a rotation or B? A appears to be a rotation. So again, in all the transformations that we're talking about, they're isometries, which means that does the size of the shape change? No, the size of the shape should stay the same. And I know sometimes when we do the examples on the board, just because of human error, your size ends up changing a little bit. But you recognize that it shouldn't, even when you try it. Okay, so this one, A, appears to be a rotation. If blue is the original and red is the new, which way did it rotate?
Counterclockwise?
Well, so it rotates this way, so that would be...
It's counterclockwise.
Yeah, that's counterclockwise. Why?
Because clockwise is this way.
Clockwise would be going down that way, like a clock turns, right? So that would be counterclockwise. Good. Okay, B appears to be a what?
Rotation. No, reflection.
Reflection. Good. B appears to be a reflection over a horizontal or vertical line? Over a vertical line. Because it appears to be reflected over that line. What?
I don't know the difference.
Horizontal and vertical? So the way they say to remember horizontal is that like it looks like the horizon. So if you look at the edge of the earth, like over, have you ever looked at like the sunset over an ocean and it looks like a flat line going this way? So that's the horizon. So horizontal goes that way. That's how they say to remember it. All right, so vertical would be that way. So if your line is going that way, it's reflected over a vertical, which on the coordinate plane would be which axis? The y-axis. If you were writing the equation of this line, though, it would be what equals? It would be like an x equals, let's say 2 or whatever. Okay? So x equals means it's a vertical line. Y equals means it's a horizontal. All right, so a rotation is a transformation about point P, and P is called the center of rotation. So essentially, you are shifting this shape. In this case, this is a what? Anyone else? All right, it's a triangle. Okay, it's a triangle. And if we're shifting it around point P, we're going in this direction. And this angle appears to be how much? Yeah, somewhere between 0 and 90, right? So maybe 30, maybe 45. So we're going to take that shape, and basically what you're going to do is you're going to turn it. There's someone where I can get like, well, it's supposed to be like a round thing. Anyway, it's not right now. So you would take it and you'd basically turn your shape that many degrees. Okay, so this little angle is telling you how many degrees to change it. All right. So when we do these, we're going to just do this part together. So we're just going to do it on the coordinate planes at your boards. When we do these, to identify if it's a rotation or something else, how can you tell when it's a rotation? It looks like if you turn it, and there might be a point, like which one of these is a pretty obvious rotation? 4 is a really obvious rotation, so that's definitely a rotation. Okay, what about 2? Why is 2 a reflection? How do you know that's not a rotation? Because you can't turn it in any way so that it ends up with the point down again until you get it all the way turned back to where it started. So this appears, Rosie, to be more of a reflection. Good. All right, what about 3? 3 is a rotation. How many times basically are you turning it until it gets to this point? 2. So when we talk about that, we basically turn things once, twice, and a third time before we're back to the beginning. So how many degrees are you talking about usually then? 90. We talk about 90-degree turns. So one turn would be 90 degrees, which basically on a clock would go from 12 to what? 3. And then we go to what?
6.
6, which would be 180. So 180 basically means it's rotating twice. And then what would be rotating 3 times? 270. And then if you rotate 360, what does it look like?
Are you here 8th period?
Yes?
And complete.
Oh, thank you. Hope none of you. All right. 360 looks like what? Well, 360 would be a full turn, so that means that what would the shape look like?
Circle.
It would look exactly the same as it started. Because if you turn something 4 times, then you're back to where it started. Okay? So this one is a rotation. And then is this one a rotation? No, because if you rotated this one, it would not look like this. It would look like a different shape. So this is a what?
A nothing.
It's not a nothing, but
It'd be like a reflection and a transformation.
a reflection and another reflection almost, basically. You'd have to like flip it and then flip it so it's upside down. Okay? So we're going to talk about those on Monday. That's a composition of transformations. Okay? So this one, I just want you to describe to me what's happening here. So which way is this rotating?
Counterclockwise.
Counterclockwise. All right, and how many degrees? 90. So this is a counterclockwise rotation, 90 degrees. All right, what about this one? Counterclockwise, and appears to be rotating about, not quite 180, because 180 would be a straight line, maybe like 130. Okay, so like 130, 120, 130, somewhere in there. Okay, so clockwise is if it rotates to the right, counter is if it rotates to the left. 180 would be like a straight line.
So if it's like that on the test, like, would it be just if we're close? How much were you going?
Yeah, oh yeah, like estimating that degrees, yes. Because I'm not taking out a protractor to measure it, so mine is an estimate as much as yours is. You might be closer to right than I am. Kiara? Yeah, so it'd be back to where it started. So literally 360 would be this shape, and then you draw it on top of itself again. Okay? All right. So we're going to do these mostly on a coordinate plane because then they're simpler to do. Because again, if they're on a coordinate plane, you have like no wiggle room. You're just counting spaces basically, or you're adjusting the coordinates. So what we're going to talk about, and this is what you're going to have to really remember when you're doing rotations, is what happens to the coordinates if you're doing these turns. Okay? So the chart that I want you guys to copy is basically how many degrees, and then what happens to the coordinates. So you've got original coordinates, and then you've got new coordinates. All right, and everything we're talking about, we're going to talk about counterclockwise, but I'll tell you what to do if that was clockwise. So we've got 90 degrees, 180 degrees, and 270 degrees. Again, why don't I put 360? Yeah, so that means where's your shape? Back to where it started, so you don't really care about it, right? Okay, so all of our originals, we just consider x, y. So if my point was originally x, y, if I rotate it 90 degrees, what happens to the coordinates? What happens to the coordinates? It becomes, what do I do with the x and the y? Flip them, and the y becomes negative. So we say negative y x if you're rotating 90 degrees.
Also, like.
So let's say your original point were 2, 6. Your new point, if you rotated 90 degrees, would be negative 6, 2. You flip them, and the y becomes negative. Okay? So if you're trying to figure out how to move it, that's what your coordinates are going to become. And we'll talk about y in a second. We'll look at it. We'll look at an example in a second that will illustrate that. Okay? All right. So 180 is just the exact opposite. So it goes from being positive xy to being negative x, negative y. Yeah, so when you're going to do these rotations, you just change all the coordinates they give you using this table. And you're just going to have to memorize them. There's only 3, so. All right, and then last but not least, you've got 270. Does anyone have any guesses on what 270 might be?
Negative y, negative x.
So it is negative y, yes. I'm sorry, it's not negative y. It does flip them. It is yx, but it's negative x. Good. So it's positive y, negative x. So then, for example, if I gave you, we'll just do a triangle so that we'll do triangle ABC. And I said this was 3, 5, 2, 1, and 6, 4. And I want to rotate it 270 degrees. That means I'm doing how many turns? 3 turns, okay. And what's my new A prime? It's 270 degrees, so what happens?
5, negative 3.
Good. 5, negative 3. I flip it, and the x is negative. What's my new B? Good. And then the new C. Perfect. 4, negative 6. Okay? So those are your flips. So all of these are counterclockwise. That's the way you're going to do them. I will always have you rotate counterclockwise. If you were going to do it clockwise, the only thing that 180 still stays the same. These two just flip. So 90 counterclockwise is actually the same as 270 clockwise. So you can just say like this basically counts for both 270 clockwise, and this counts for 90 clockwise because it's the same thing. Turning it 3 times to the left is the same as turning it once to the right, right? Like if I'm walking in a square, like if I needed to get from my room to whose room's over there? Panazzo's? Somewhere over there? Okay. I can either go 1 turn to the right, or I can go this way and go left, left, left. Right? So that's the same thing. So these are all the same. I will only ever really do them in counterclockwise. So that's all I want you to memorize. Okay. Now, the reason this works, I'm going to try the turning thing that I was doing again, but we'll see if it works. Okay. So we're just going to do this with a point rather than a shape, just to illustrate this for a second. But let's say, pick a point for me in the first quadrant. 4, 1. Okay, so 4 over 4 up 1. All right, so there's my point, 4, 1. I'm going to try this from my computer. What? Okay, so see how this is in the first quadrant? If I turn it once, like I turn the whole coordinate plane once, where does it appear to be now?
Negative 1.
So it appears to be in the 1, 2. So now it appears to be in the second quadrant, and it looks like it's what point now?
Negative 1.
-1, 4. And it was, initially, Melanie gave us the point 4, 1. So what happened to those? Flipped and became negative. That's where this comes from. Does that make sense? Yeah. So if you turn it, what you're actually doing when you turn this shape is if I turn it once, I'm basically taking it from the first quadrant into the second. If I turn it again, I just did it, so I know I can't. No, it's because I can't touch that part of the board. I know. Okay, so if I turn it again, now it appears to be in the what quadrant? Third, and it looks like it's at the point
-4.
-1, which is exactly opposite of our original, right? And if I turn it a third time, now it looks like it's in the fourth quadrant at 1, -4, which is exactly what would happen if we did it how many times? 270. Okay, so that's where these like numbers are coming from. They're not like pulling out of nowhere. It's not like we just say like, oh, I think I should randomly flip the x and y's and make one of them negative. That's what happens if you physically take the points and rotate them. The problem is doing that on paper, like it's really easy on the smartboard because I have a little thing that makes the turns happen. But if you try to do that on paper, you can do it. If you graph your point and just turn your paper, it will work like that. So if you ever forget these, that's a way to kind of like back up. So if you graph your picture and then physically turn your paper however many times you're supposed to turn it, it will look like it's in a new quadrant, and just write down what those points are. Okay? So that's kind of the shortcut of like, I can't remember what the new coordinates thing's supposed to be. So draw it on your paper and then physically turn your paper however many times you need to. So if it's a rotated 90 degrees, turn it once and then it should look like it's in the second quadrant. Turn it 180 would be 2 turns. 270 would be 3, and then 360 would be back to where you started. Okay, so that's just a backup if you can't remember this table. All right, so let's try this one then.
So that will be 90 degrees.
That would have been 90, yeah. All right, so we're gonna do rotate ABC with these vertices, 2, -1, 4, +1, and C, 3, 3 by 90 degrees about the origin. So I want to rotate it 90 degrees, which means I'm going to go from x, y to what? -yx. So I'm going to flip them and make the y negative or a positive depending. It's opposite. So make the y opposite. So in this case, it would be 1, 2, good. And then b would become, and c would be 3. Good.
Oh, so it like. Also.
It flips it and it makes it opposite. So if it was negative, it becomes positive. Okay, so now I just plot this. I don't ever do the original, but you can if you want to. You just don't have to. Okay? So my new point is 1, 2, and -1, 4, and -3, +3. All right, and that's where my rotation is. So again, if you have this table with you, you should be able to just flip them to your new points and then graph them. But you need to memorize that table, okay? And if you don't, you can again just turn your physical paper. It's hard to do when you're at the boards though. Okay. All right, go ahead and try these two. Just try graphing your new ones. The first one is 180, the second one is 90.